So in the previous class we have studied this first shifting property. What does this say? It says that if you have the Laplace transform of some function f of t as f of s, then the shifting property, it says that the Laplace transform of the same function when multiplied by e to the power at, then it would be nothing but this particular function where you have now replaced s with s minus a. And what is this a? This is the coefficient of e to the power a t. This is the coefficient of t. So this is the shifting property. So now if you apply the shifting property onto e to the power at sin bt, we know what is the Laplace transform of sin bt. It is given by this formula b upon s square plus a square. So what we have to do, you just have to replace s by s minus a. So when you replace s by s minus a, you would have this as the result. Next you have the Laplace transform of, similarly if you calculate all this Laplace transform, because we know Laplace transform of sine hyperbolic bt, the formula is b upon s square minus b square. Now because we are multiplying it with the term e to the power at, so what we are doing in effect, we are replacing this s by s minus a. So what does this become? This become b divided by s minus a whole square, this term minus b square. Similarly you have these two formulas as well. And then we have seen various questions regarding this shifting property. So the next topic for today's is multiplication and division with t. So multiplication and division with t. So what would be the Laplace transform whenever you have the multiplication of some function by t and the division of some function by t? So see, for the first case, if we suppose the Laplace transform of this function f of t is known to us, that is capital F of s, this is known to us, then the Laplace transform of the function f of t when multiplied by t, what would be that? It would be the derivative minus the derivative of this f of s. And in general, if we multiply the given function by t to the power n, this power could be anything, so we call it n. So this would be equal to minus 1 raised to power n, the nth derivative for this f of s. So this is the formula that you should remember. So here if you substitute n is equal to 1, so you will be getting this formula back. So this is the formula. Now you see, whenever you multiply by t, you have the derivative over here, and when you divide by t, you would have integration as a result, right? So before moving further, let us first trying to prove this one, how this is true. So for the proof, what we will do, we will calculate the we know the Laplace transform of this f of t, that is given to be capital F of s. So we can apply the definition onto the left hand side. So we would have integration from 0 to infinity f of t e to the power minus st dt, that is equal to f of s. So now what I can do, I can differentiate this one, I can differentiate with respect to s on both sides. So now on the left hand side, when I have to differentiate this whole integration term, integration from 0 to infinity f of t e to the power minus st dt, so I have to apply the Leibniz rule for integration. So I'll just tell you what is that. So on the right hand side we have f dash s. So now what is this Leibniz rule for? What is this Leibniz rule? What is this Leibniz rule for taking the derivative under integration sign? So this rule says that if you are to perform the derivative of some quantity with respect to of this integral term, so you have f of t e to the power minus st dt, right? So it would be nothing but integration within the same limits And firstly we'll perform the partial derivative with respect to s of whatever is inside. So inside is f of t e to the power minus st, and dt would come as such, and then plus the derivative of the upper limit and the value of this function f of t e to the power minus st evaluated at this upper limit, minus it would be the derivative for, so it would be the derivative of the lower limit and the whole function f of t e to the power minus st evaluated at this lower limit. So this is the formula that we shall use here. So when you use this formula, so what would you have? Let us see that. So if I apply this formula here, so on the left hand side I would have the integration as such 0 to infinity, then the partial derivative of this particular term with respect to s.
Hello, ma'am.
Hanji. So here it would be integration from 0 to infinity and then the partial derivative with respect to s of this term f of t e to the power minus st, okay? Then plus the derivative of this upper limit. Now upper limit, this is a constant quantity, so its derivative would be 0. So 0 into something would be 0. So we will write it 0. And then minus the derivative of this lower limit. And lower limit again is a constant, so its derivative would be 0. So 0 multiplied by anything would be 0. So this is what we got after applying this Leibniz rule. So we would have integration from 0 to infinity, the value of this derivative. Now because we are taking partial derivative with respect to s, so this f of t would come as such, and then we'll take only the derivative of e to the power minus st. So its derivative would be e to the power minus st multiplied by minus s dt. So this is what we got from here. So what we have to prove? I'm sorry, because here it won't be minus s, it would be, because we are taking the derivative with respect to s, so the coefficient would be required here, so it would be minus t into dt. So therefore we have from here we got integration from 0 to infinity f of t e to the power minus st multiplied by minus t f that is equal to f dash s. And what is this? If you combine all these terms, so 0 to infinity, it would be minus outside t into f of t e to the power minus st dt. So I have combined this term with this term, and on the right hand side I have f dash s. So now you see, by definition of Laplace transform, what is this term? This is nothing but the Laplace transform of t into f of t. So this is equal to f dash s. So from here what we got? We got that the Laplace transform of t into f of t, that is equal to minus f dash s. So now again, this is the one result that we got. Now here, if you substitute in place of, now if we substitute f of t as t into f of t. So instead of this thing, instead of this f of t, if I write now t f of t, so I would have Laplace transform of t as such, then t into f of t. So what would be this? This would be minus this minus would come as such, and then whatever is this one, I am applying the same formula again. So the formula here is Laplace transform of t f of t, that is equal to minus f dash s. So now this is what I have. Now here, instead of f of t, what I am doing, I am substituting t f of t. So that means I will apply this formula again. So minus would come as such, and then according to formula, I would have minus the derivative for this term. It would be f double dash s. So I would have f double dash s to be this term. And similarly, if you keep on doing this, so if you substitute this f of t is equal to t f of t again and again, so at the end what will you have? You will have the Laplace transform of t to the power n f of t, that is equal to minus 1 raised to power n, the nth derivative with respect to s of the term f of s. What is this? This is minus 1 raised to power 2, the second derivative with respect to s of the term f of s. And what is this term? This is minus 1 raised to power 1, the first derivative with respect to s of the term f of s. So we have generalized our result, and this is the final answer that was required. So this is the formula. So let us look at one example corresponding to this. So say we have this question. They are saying find the Laplace transform of t into sine of 2t. Now clearly you can see, you know what is the Laplace transform of this sine 2t. We know. So for the solution, we already know what is the Laplace transform of this sine 2t. This would be 2 divided by s square plus 2 square. Why? Because the formula is Laplace transform of sine at, that is equal to a divided by s square plus a square. This is the formula. So this is nothing but f of s, right, by notation. So now if I wanted to calculate the Laplace transform of t into this function f of t, so t into sine 2t, so according to this formula, if I am multiplying with t to the power 1 here, so I would have minus 1 raised to power 1, and then the first derivative of this quantity f of s. So what is this quantity? It is 2 divided by s square plus 2 square. So it would be minus 1, and then here 2 would come out, right? 2 would come out, and then I will take the derivative for this particular quantity. So what is the derivative for this s square plus 4 raised to power minus 1? So this I have to perform the derivative. So it would be minus 2 and then minus 1 s square plus 4 raised to power minus 2, and then according to chain rule the derivative of this term. So it would be 2s. So finally I would have 2 into 2s divided by s square plus 4 raised to power 2. So I have 4s divided by s square plus 4 raised to power 2. So this is the final answer. So this is as simple as that, because you know what was this derivative sine 2, what was this Laplace transform of sine 2t. So what we have done, we have just multiplied by t to get this answer. So similarly, if you have another example, this states that find, question number 2, it states that find the Laplace transform of t square e to the power minus 2t. So now for the solution we have Laplace transform of t square e to the power minus 2t. Now we know what is the Laplace transform of e to the power minus 2t. It is nothing but 1 upon s minus minus 2, because what is the Laplace transform of e to the power 8t? It is equal to 1 upon s minus 8. So using this formula we have this Laplace transform. So this is 1 upon s plus 2. So this is f of s. So now according to this formula, because the Laplace transform of t to the power n f of t, this is equal to minus 1 raised to power n, the nth derivative with respect to s of f of s. Therefore, the Laplace transform of t square e to the power minus 2t, it would be minus 1 raised to power 2, the second derivative with respect to s of f of s. What is f of s? The Laplace transform of this term. And what was that? That was 1 by s plus 2. So it would be, so you have to perform its derivative twice. So when I perform its derivative one time, what would be this? It would be minus 1 upon s plus 2 whole square, and then when I perform its derivative again, it would be 2 times s plus 2 raised to power 3. So this is the answer. So now if you look at it more closely, what would you have? So we also have another way to solve this. What is that? That is more easy one.
Yes, ma'am.
So here what we do instead is we will first calculate the Laplace transform of this t square, and then we can apply this shifting property. So what is the Laplace transform of t square? That is equal to 2 factorial divided by s cube, right? So now according to shifting property, by the shifting property, says that the Laplace transform of some function f of t into e to the power at, this is nothing but f of s minus a. So in this case our a is minus 2, so what we will do, we will replace this s over here by s minus of minus 2. So our final answer would be 2 factorial divided by s minus of minus 2 would be s plus 2 raised to power 3. So now you see this is exactly same as that we got over here. So you could proceed with any method that you would like. So this is the multiplication with t to the power some function with t.